Hey everybody, this is Mr. Walsh, and we are talking about the stations activity from the Lewis dot structures. So we should be able to answer these questions pretty straightforwardly, and there's a whole bunch of different questions on here to type, so that's why I like the stations activity. But let's get started here. So we're going to draw the structure of these compounds. So in order to do that, we're going to do count the valence electrons. 7 plus 7 plus 7 plus 7, so that's 28, so that's 32, and then we're going to draw a skeleton structure. So that's minus 8, so we have 24 left, and then we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so that's 24. And then we do the same thing here, 6 plus 7 times 2, so that's 14, that's 20 electrons. So we'll do O, Cl, Cl, and so that's 4, so we have 16 left, so 2, 4, 6, 8, 10, 12, so subtract 12, we're down to 4, and those extras go around the central atom. Okay, so that's the first station. Okay, so name and draw the structure. So the name, this is going to be nitrogen. So remember, when the first one doesn't have a prefix, we drop it. So mono, we don't say mononitrogen. And so this is nitrogen trifluoride. And then to draw this again, we're going to count. So that's 5 plus 7 plus 7 plus 7, or 7 times 3. And so that's 26. So we're going to go N, F, F, F. So that's another 6. So we're down to 20. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18. That's down to 2. The extras go around the central atom. Okay. So now station 3. We do the same thing, different ways, different types of questions, but all kind of getting at the same things. Okay. So it says, what is the formula of sulfur trioxide? So sulfur trioxide. And we're going to draw the structure of that. So now we have to add up. So we have 6 plus 6 times 3. So that's 24. Okay. And we draw the structure, put sulfur in the middle, oxygen, oxygen, oxygen. So we subtract 6, so we're down to 18. We'll go 2, 4, 6, 8, 10, 12, 14, 16, 18. So we're done with electrons. And so now the central atom doesn't have 8 around it. So we're going to take one of these and we'll get rid of this one. And so now that makes a double bond. Okay. So how many bonding domains does the structure have? So this is how many bonds, okay? We don't have to call them bonding domains, but remember, a double bond counts as one bond. Even though it's 2 lines, we call it a double bond. It's still just one bond, and we call it double bond. So this is 1 bond, 2 bonds, 3 bonds. So this is 3. And then, do they connect the same elements? So we're looking at 1 bond. So we have a sulfur on one side and an oxygen on the other. So that is different elements. Okay, if I can spell different, right? Different. Okay, good. Okay. So that's what we have for station 3. Okay, station 4. What is the structure of the compound shown? So here, I think it's better to give a formula and then we can draw it. Okay, so this is 5 plus 7 times 3. So that's 26 electrons. We'll put phosphorus in the middle. We'll do I. Down to 20. We do 2, 4, 6, 8, 10, 12, 14, 16, 18. It's lots of 6 electrons around the exterior atom. So we put 18. We're down 2. The extras go around the central atom. So that's that compound. Okay. So it says give the formula for the following structures. Pretty straightforward. We just have to count. Remember, the central atom almost always gets listed first. So this one we're going to do S, and then 1, 2, 3, 4, 5, 6. And I even cross them off just to make sure I count for them all. Sometimes my eyes play tricks on me. I'm old, so that's what happens. So SF6. I didn't ask you to name it, but you could name it. Sulfur hexafluoride. Okay, and then this is C2H6. C2H1, 2, 3, 4, 5, 6. Okay, so that's station 5. And then the last one here is names of the following compounds. Okay, and I know that this one has a little bit of weirdness with this bonded to nothing, but just go with it. Okay, so again, the central atom kind of gets listed first, and you can kind of see that there's P's in the middle here, all around. So we're going to do P2, and then O, 1, 2, 3, 4, 5, O, 5. And then this one is going to be S, 1, 2, 3, 4, then O, 1, 2, 3, 4, 5, 6. O, 6, and it's asking for the names. So now that we have the formulas, now we can give the names. So this is diphosphorus, pent oxide. Okay? Remember, when it's oxygen, you don't put the A in there. There's no A. It's not pentaoxide. Okay, and then this one, this is tetrasulfur. Okay, sounds weird, but that's what it is. And then let's see, hexoxide. I don't know any other word with 2 X's in it like this. So anyway, it's hexoxide. And again, because it's oxygen, you don't put that A in there. Okay, you'll say hexoxide. Okay, so there you have it. This is the station's activity for the end of Lewis dot structures. Have a great day, everybody.